So let's do a similar example to what we just did. We're pulling at an angle. So we got a surface, we got a mass here. Let's say that the mass is 17.5 kilograms. And I want to pull on this at some angle theta. Okay, and I want to pull with a force of 225 newtons. Now, I want to pull, but I want to drag it horizontally. I do not want to lift it off the surface. Okay, so I don't want it coming off the surface. So you look at it and say, well, why is this even an option? Well, we got mg pulling down. We got F pulling at some angle theta. Well, what is mg? Mg in this case, 17.5 kilograms times 9.81 meter per second squared. That turns out to be 172 newtons. Well, F is 225 newtons. So that means if I were pulling straight up, that's bigger than mg, and I'd be lifting it off the surface. Okay, and so if I did that, if I lifted it off the surface, what would be the acceleration? So in other words, assume theta equals 90 degrees. Okay, so what would be the acceleration in that case? Well, you look at it and say it's accelerating upwards, so F minus mg equals ma. So that means that A is going to be F minus mg over over m. So if I did that, so I had the 225 minus the 172 and divided by 17.5, that would be an acceleration of 3.03 meter per second squared. Okay, but I don't want to do that. I don't want to accelerate it off the surface. So what I want to know is, given that I don't want to do that, okay, I want to know what is the max theta so that it does not go off the surface. Okay, so we got mg pulling down. And so that means I want my y acceleration to be 0. I do not want it to come off the surface. And so, well, if y acceleration 0, that means that we're in equilibrium. Force up equals force down. So that means that F sine theta equals mg. Okay. Well, okay. So remember, we got a normal in here. So I'm going to say, remember, the normal is whatever it needs to be. So the normal from a previous problem is going to be mg minus F sine theta. Now, the smallest the normal can be is 0. Okay. Now, a negative normal means it'd be pulling downwards. It'd be like we had glue holding it downwards. That'd be like a negative normal. Okay. But we don't have that. So we're going to say, I'm going to let it get as small as possible and let it go to 0. In that case, I can say that F sine theta equals mg. Okay. And so in that case, sine theta equals mg over F. So theta is the arc sine of mg over F. Okay, we have all those numbers, so I can plug that in, and that's 49.7 degrees. So that means if I pull it at any angle bigger than 49.7 degrees, I'm going to actually pull it off the surface. And so I'm going to lift it off the surface rather than sliding it along the surface. Any angle less than that is going to move horizontally. And there will be a normal force. Another way of looking at it, the normal is going to be greatest. The normal will equal mg if theta is 0 and I'm pulling perfectly horizontally. The more I pull upwards, the smaller the normal will be until I'm pulling straight upwards. Okay, or until I'm pulling at this angle right here. If I'm pulling that angle right there, the normal drops to 0, and any larger angle, well, if the normal cannot go negative, that means I'm pulling it off the surface. So that's what that implies.